So let's actually make a whitewater sim. I'm gonna move all this stuff down a little bit. So make a .network. We'll call it sim whitewater. What's going on there? Okay. Sim whitewater. Still can't believe Houdini has not crashed on me yet. Anyway, whitewater object, whitewater solver. And this little setup has a lot of the important things built into it already. In terms of gravity is already built into it. And in terms of like even the collision and whatnot is built into the solver. So for some reason you don't need to make a static collider or a gravity node. So just be aware of that. I like to turn on color particles by depth just to see. The whitewater solver itself, we do need to have these limits hooked up. So let's go find, for the 100th time, the limits that we came up with over here. So size to this, center to this. As I was just starting to say, the collision is the boat. The collision is handled a little differently here, to be fair. You can the whitewater can like know to stick to the colliders and stuff rather than just get in the way. SDF name means what is the literal name. So here it is, collision on the incoming SOP. The voxel size is here. We can hook that back to what we just came up with on our whitewater source, which was actually in the out ocean splash. So here it is, whitewater source voxel size, like so. There you go. As it helpfully points out, voxel size, the volume is used for blah, blah, blah. Voxel size should be at least twice as large as whitewater scale. And I agree. It's kind of like Flip in the sense that it uses voxels for one size of the simulation and then multiple particles within a given voxel. So let's go down to 0.05 for the actual whitewater scale. We definitely want state attributes. This should probably be on by default. This creates some attributes which are spray and bubbles and foam, depending on where the particles are in the sim and what they're doing. We're going to use those to split them out later for rendering and even actually for some further simulation. I'll turn on closed boundaries here, but I don't think it will really matter. I'll do the same that we did before. We keep the top Y open. And honestly, after that, we just need to do the emission and the volume sources. The volume source refers to the actual liquid simulation. So that's where the actual liquid's velocity and sign distance field, which refers to the surface, comes from. So take the compressed and put that there. And the emission source is, again, of course, what we just came up with. So that goes there. And that honestly should do it. The sim itself should, or would be, I should say, would be fast, except that it has to read in these heavy, I mean, the compressed ones are better than nothing, but it does have to read them in. And that's actually what takes most of the time. So we're reading, I should say, reading that in and then also running it through that mask. But there you go. So you can see our result coming through here. So there you go. So that's looking nice.